All right, I'd like to talk about the concept of pH. Whenever you have pure water in a container, you will find that occasionally two water molecules will come together and they'll transfer hydrogen from one of them to the other. So in the process, you make an H3O plus, which is a hydronium ion, and an OH ion. So this is our acid ion and this is our base ion. What's interesting about this is notice that in pure water, it has to be neutral then, because this is your acid ion, this is your base ion, and you're always going to have them in equal concentrations because they're always made by the collision of two waters. At 25 degrees C, it turns out that the concentration of your OH and H3O will be 1 times 10 to the 7 each. Now we do something where we get what's called an ionization constant for water, where you multiply those two numbers together, the concentration of the OH times the H3O. Well, if you take 1 times 10 to the minus 7 times 1 times 10 to the minus 7, of course you get 1 times 10 to the minus 14. Since the concentration of hydroxide and hydronium are equal in water, water is neutral. Now, if in some way, if I can dissolve something in this water that will drive up the H3O, then that water will be acidic. If I put something in there that will drive up the OH, then it'll be basic. So again, the concentrations come into play here, but notice how in pure water they're going to be the same. Now, since the ionization constant is known, it's the product of the two numbers, and it's always 1 times 10 to the minus 14 at 25 degrees C. If you know either the hydronium or the hydroxide, you can find the other by dividing it from 1 times 10 to the minus 14. So as an example, determine the hydronium and hydroxide concentrations for a solution that has 1 times 10 to the minus 4th molar HCl. Well, this is a strong acid, so we're going to assume that it's going to completely ionize, and that means my concentration of my H is 1 times 10 to the minus 4, and my Cl is 1 times 10 to the minus 4. Well, I'm not really worried about the Cl, but if I know that H plus, which as I've said before is the same thing as your H3O concentration, well then I can figure out my OH concentration by taking 1 times 10 to the minus 14, dividing it by the 1 times 10 to the minus 4, which is my H3O. So my H3O is 1 times 10 to the minus 14. My OH then would be 1 times 10 to the minus 10. Notice that if I multiply these, again, I get 1 times 10 to the minus 14. So as long as you know one, you divide it from 10 to the minus 14 to get the other. Another example, HNO3, nitric is another strong acid. If I know the concentration of the nitric acid, then I know the concentration of the H3O. I simply take 1 times 10 to the minus 14 divided by that, and I get 1 times 10 to the minus 11, which is my other, or OH concentration. Now in number 3, I have a strong base. Sodium hydroxide is a base. And again, if I dissolve this, I'm going to get 3 times 10 to the minus 2 moles of Na, 3 times 10 to the minus 2 moles of OH. So again, I know my OH then would be the same. So notice over here, that's my OH concentration. To get my H3O, I take 1 times 10 to the minus 14 divided by the OH, and that's what you get. That's your H3O. Now notice with something like calcium hydroxide is a strong base which will release both hydroxides. So if my concentration of calcium hydroxide is 1 times 10 to the minus 4, then my hydroxide concentration, my Ca concentration is 1 times 10 to the minus 4. But my OH will be twice that number, or 2 times 10 to the minus 4. So again, to get the H3O, I simply take and I divide 10 to the minus 14 divided by this to get the other. Now, this comes into play in what's called your pH scale. And the pH is defined as the negative log, the base 10 log, of the hydronium ion concentration. The term pH comes from French for pouvoir hydrogène, or hydrogen power. And again, you simply take the negative log of the H3O concentration. So if I take the negative log of 10 to the minus 7, if I just take the log of that, I get minus 7, because that's what log is. What would you raise 10 to get 10 to the minus 7? Will be minus 7. Negative means I get rid of the negative, so that gives me a pH of 7, and that's why this is neutral. Now, if my concentration of H3O goes up to 1 times 10 to the minus 6, again, take the negative log of that, you get a pH of 6. If my H3O concentration continues to go up, to 1 times 10 to the minus 5. Of course, your pH is 5, and so forth. And again, 1 times 10 to the minus 1 is a much greater value than these guys down here. So again, this would have a pH of 1. So notice that as I approach 0 and go in the lower direction, my H3O concentration is increasing, and this is becoming more acidic. If my H3O concentration goes down, the opposite's occurring. So my concentration goes 10 to the minus 10, 10 to the minus 11, 10 to the minus 12, and so forth. Take the negative log, and that's your pH. Now, there's a concept called pOH, which is the negative log of the hydroxide concentration, and it just works as the kind of the inverse of the pH. Your pH and pOH, because the product of your H3O and OH is always 1 times 10 to the minus 14, your pH and pOH will always add up to 14. So if you actually know the pOH is 5, then you know the pH is 9, and you can actually go back and forth that way very easily. Here's just a table of some examples of various compounds. Gastric juice, the stuff in your stomach, very low pH because you're digesting food. Your blood is actually slightly basic. It's a little bit above 7, 7.3 to 7.5. Pure water is actually 7, obviously. Milk is slightly acidic, which surprises folks. Rainwater can vary. It is acidic, but again, that depends a little bit on where you are. Certain areas of the world have a little more acidic than others. So just in general, recognize that if the H3O and OH are equal, that means it is a neutral solution, and your pH will equal your pOH. Your H3O is equal to your OH, which is always 1 times 10 to the minus 7, so the product of them would be 10 to the minus 14, which we've talked about. And again, your pH and pOH will both equal 7. If it's acidic, that means your H3O concentration is greater than your OH concentration. That means your pH is greater than your, less than, than your pOH. And again, that means my H3O concentration is greater than 1 times 10 to the minus 7, and my OH is less than 1 times 10 to the minus 7. And therefore my pH is less than 7, and my pOH is greater than 7. And obviously, all that is completely reversed when you get to the basic solution. So to calculate the pH, you are simply going to take the negative log of the H3O concentration. If only the OH concentration is known, you can either take 1 times 10 to the minus 14, divide it by the OH, and then that will give you your H3O, and then take the negative log of that number. Or you could take the negative log of the OH concentration, which will give you the pOH, and then take 14 minus that number, and of course that would give you then your pH as well. To calculate the hydronium concentration from the pH, let's say I told you that the pH was 5, and I said, what is the hydronium ion concentration? We're going to do the anti-log or inverse log, or 10 to the x. And again, on some calculators it's second and then log, and then you hit negative pH and hit enter. If you have a 10 to the x button, all you would do is, if I said to you the pH is 4, you would go 10 to the x, and then for your x you're going to put negative 4. Enter, and then that'll give you your H3O concentration. So you can go back and forth between your hydronium and your pH, whether you take the log or the anti-log or 10 to the x. The molarity and ion concentration are only equal in strong acids and bases. So when I did things like we just did a moment ago, where I would say to you KOH, this is the concentration of KOH, and I said to you this is the OH concentration, that only applies in strong acids and strong bases, because they completely dissociate. Weak acids and weak bases, you'll notice that is not the case. So I have 1 times 10 to the minus 2 molar NH3. Notice that is not my OH concentration. So you can only really do that if you have strong acids or strong bases. So let me show you how you could do some problems with this. In this case, I'm telling you that you've got 0.00045 molar HCl solution. So what is my H3O concentration? Well, this is a strong acid. Hydrochloric acid is a strong acid. There is my H concentration, so that is going to be my HCl. So that is going to be my H3O concentration. So that is going to be 0.00045. Now, how do I get my OH concentration? I'm going to take 1 times 10 to the minus 14 divided by this, and when I do that, I get 2.2 times 10 to the minus 11. Now, how do I get my pH? I take the negative log of 0.00045, and when I do that, I get 3.3. And to get my pOH, I take the negative log of 2.2 times 10 to the minus 11, and I get 10.7. Or another way to do that is to simply take 14 minus 3.3, and you get 10.7, because remember I said that your pH and your pOH will always add up to 14. And jumping ahead to number 16, given these pH values determine the OH concentration and indicate if it's acidic, basic, or neutral. Well, if the pH is 7, we've said before, I kind of know already that my H3O and OH are both going to be 1 times 10 to the minus 7. And of course this would be neutral, so we're going to be neutral in that case. Now over here you have a couple of different ways you could do this. This is the pH, so I could take 10 to the negative 11.5, get my H3O concentration, and subtract that from 1 times 10 to the minus 14, and that would give me my H3O. Or I could simply take 14 minus 11.35, which would give me my pOH, which would be 2.65. And then again, I could take 10 to the negative 2.65 on my calculator. That will then give me, so I'm taking this is the pOH here, and then I'm raising 10 to that number, and that'll give me my OH concentration, which in this case would be 2.2 times 10 to the minus 3. So that would be your answer there. And then you can kind of keep going along with the same way. Again, I can do these for all of these problems.